G'day explorers, grab your colouring in pencils, let's talk about the water cycle. This here is your vocabulary. I would like you to pause the video here and write all this down so you've got all this to refer back to as we move through the lesson. So let's talk about moving water. One of the good things about a liquid is that if it's not in a container that's shaped like that, it's not going to stay still. It's going to move. And even then, it's going to be closed in. Otherwise, it's still going to move, as you'll see in a minute. The water cycle is how the water moves around the globe. And it is global. It's not a local thing. Like, we're talking very large distances that water moves throughout its time. We're a pretty wet planet. 71% of our surface is covered in water. What makes that amazing? What makes that really, truly amazing is that everywhere we have been in the universe where we have found liquid water, we found life. And to be fair, that's Earth. But that's a whole range of environments on Earth where we found liquid water. Now, we're just starting to find liquid water on, or traces of liquid water, or evidence of liquid water on other planets. Does that mean there'll be life? Who knows, right? Like, some of these planets have hydrocarbons and all the other things. And maybe that's the next step of our geographical explorations, is to sort of head interstellar. So yeah, but wherever we find water on Earth, in even really extreme situations, that's where we find life. So water moves in a cycle around the planet, and it recycles throughout time. This means that it is a renewable resource. Even when we use water, generally, it exits as water. It enters back into that cycle. And that's because water is extremely chemically stable. So I remember as a kid, there were always like these myths of how some petroleum company had started, had made a car that runs on water. And it's actually not possible. The reason it's not possible, we can have cars that run on hydrogen. We can split the water to get hydrogen to run the car. That's a different thing. But a car running on water, aside from steam, is not possible because water itself is a very low energy molecule. It's sort of, things tend to move towards that lower energy as they move through, and that makes water really, really chemically stable. It's a really efficient way for hydrogen and oxygen to be together, so it tends to stay that way. So when we use water, it usually re-enters the water system at some point as water. We can have a look at precipitation. Precipitation means to fall out of. Basically, that's what the word means. In this case, we're referring to water falling out of the sky, whether it is fog, vapor, rain, snow, right? One of the things about water is it moves around. It's not spread evenly. So we have a lot of precipitation through the center of our planet here, and that's the really tropical regions. And we can see that there is actually a bit of a range, right? Like, there are certain longitudes where precipitation seems more common. And that doesn't mean these other places don't have access to water. For example, we see great artesian basins right in these areas where there's not a lot of rain. So the water is present at different parts around the globe in different forms. Okay, so one of the things that has changed, and this is not what we're talking about, when we're talking about the water cycle, we're not talking about the long changes of water over time. But the water cycle is affected by long climate changes. Like, for example, here we see two glaciers. This is a glacier here. This is a glacier here in 2009. This is the same glacier in 100 years beforehand. Now, that means that the water cycle's changed in a fairly significant way. Like, 'cause that's a huge chunk of water, right? Like, that's, kilometers. Now, that water is still somewhere. And it tends to be in the wet part of the cycle. So not the solid part, like the ice part. It was locked up in ice, and now it's moved around into rain, clouds, the ocean, and as such thing. And that's where we get worried when it comes to climate change about the oceans rising, because when this water leaves these icy zones, they enter, the water cycle as liquid water. It still stays as water. So here's our water cycle. And because it's a cycle, it has no real start, but we'll start here. Here we've got our big oceans, right? And at our oceans, we have evaporation. This means the sun beats down, it gets warm, and the water evaporates into, vapor, steam, and it moves up into the clouds. It condenses, which means it sort of comes back into liquid drops, and they sort of hang around each other. The clouds originally form around dust, like little dust particles, and builds up around it. And then we have transportation, where the clouds move, and precipitation. The precipitation can happen here. If it happens over the ocean, it'll just keep going back up. If it happens, clouds are bigger than you think they are. It's pretty crazy. Look up the size of clouds and just be blown away. So they move really far, and it moves over the land. And then they hit roughly where a mountain is. And that change in pressure, you can look at that at a different point. It can cause precipitation. So we have rain or snow fall onto a mountain. Can be rain or snow, and that condensation, it will drip down, and it'll run off, and you will hit some surface flow. This is where the water flows across the surface of the thing, and it can travel really long distances. We can have percolation, infiltration, then percolation. Instead, infiltration is where it goes through the soil, percolation is where it starts to move through the rocks, and we get groundwater. And this groundwater moves through, and some of that groundwater makes its way back to the ocean. Some of that groundwater gets taken up by plants. Now, a really interesting thing is that groundwater, it goes through, that in the plants lose a ton of water, right? Like they use a ton of water and they lose a lot of it through a process called transpiration, or, as it said earlier, evapotranspiration. And that's because the water starts at the roots, travels up, that's the transpiration part, travels up to the leaves, and the leaves have these little holes in them called stomata, and out of the stomates, or the stomata, the water evaporates off, so that's why it's evapotranspiration. And it goes up into the clouds, and then it falls back down, and we can see that it is a true cycle. Now, what powers it is the sun. The sun is what puts the energy in to drive the whole thing and to keep it going. When the sun is hotter, or when there's more heat energy stored in, we have less time as snow. We get more sublimation, which is where the ice goes straight from solid to a gas. We have more evaporation that goes up, and then more raining in the oceans rise. If we have less heat, our ice starts to build up, and our water cycle slows down a bit. So that's our water cycle. Now, we've had a look at our water cycle. It's been presented there. It's really cool. Let's look at the geographical tools that have been used in making our water cycle, because it's important to understand what we're looking at. So this is a visual representation of water movement. Pretty straightforward. And we've done this for two reasons. One, I can use it to explain. Okay, I can make a water cycle like this to explain to someone else how it all moves about. Alternatively, I could do this water cycle myself to help organize my thinking. So if I was going to make this for me, just to organize my thinking, I would make a much simpler graphical representation, but I would still do it like in my study or my training to work out how things work to help organize my thinking. So that's where a geographer or an explorer would use these geographical tools. So I'd use this visual representation to clarify my own thinking or to explain it to someone else. I hope that made a lot of sense. So if you have any questions, put them in the comments below and I'll get back to you as quick as I can. Thank you for watching. Don't forget to go outside and keep exploring.